There we go, it's on. Okay, so then we just flip the thing over and we put some nuts on the end of those screws that have come through, and our battery holder is in position. Nut on there, and a nut on this one as well. Now that was quite a tight fit, but we got there in the end. I'll just use my my pliers here and just tighten that nut down so that our battery holder doesn't fall off. And I'm scratching my beautiful so what we might do is just hold the nut and spin the screw with our Phillips head screwdriver. And then we have it. We'll grab our wires from our battery holder and we'll just feed them through the base so that we can then plug them into our Arduino when we need to. So coming out of the center hole of this chassis, we have 4 wires for the motor and 2 for the power. And that is our completed, not completed chassis, but that's all the bits and pieces we need aside from sensors and the Arduino and the motor shield and everything else. So what we can do now is we can put our Arduino onto the top of the chassis. Now, because the chassis is insulated, we don't have any issues with it, with the bottom of the circuit board touching this. If this was metal, if there's any metal parts on here, that could cause a problem. And what we're going to do is we're going to actually take out 2 of the screws that are holding our caster wheel, because they line up really nicely with the holes on the Arduino. So we're going to take these out, and it just saves us having to find somewhere else to put the Arduino. It's a good spot for it to be anyway. So we'll take those 2 screws out. The caster will stay where it is because it's got 4 holding it in position anyway. So we take those screws out at the back. We grab our Arduino, which is our controller board, and we put it, as you can see on the Arduino, you've got 2 screws holes there, and this is the end where you plug in your USB cable, and that's a DC power. So this goes like that, and we just put our screws back in through the Arduino. We put it through the Arduino board and into that standoff that holds that coaster wheel, and that will hold the board in position nicely. Now you could always, if you didn't want to do this, if you wanted to put the board somewhere else, it's not imperative that it go in this position. You could always put it somewhere else with double-sided tape if you wanted to, if you found that this was a little bit difficult for you. But this works quite nicely. It does push the board up a little bit, like it's jumping up in the air, but I wouldn't worry about that too much. In fact, that second screw probably won't line up as well as you would like it to. So guess what? I'm just going to put it back in again, because with this circuit board, it's not imperative that you have 2 screws holding it in position. One will do the trick, because it's not a mechanical part, it's just got to stay where it is. So there we have it. We've got our Arduino board on there now. We've got our battery holder. Drink some more coffee. So now we need to get our eyes on the robot, and that we're going to use this little mini breadboard. And what's really nice about this is it comes with some double-sided tape on it already. So they've made it very easy for us. So we just peel that off, and we sit this breadboard on the front of the robot chassis, because that's where our eyes are going to be. Now, what's great about this, front and center, stick it down, it's there now. Now what's really good about these breadboards is you can build circuits on here, experimental circuits, and it's really good for prototyping, which is testing out a circuit before you actually build it. And then we need to get our sensor. Our sensor is our ping sensor here, and this basically sends out a little sound wave, a little burst of sound, and it listens for how long the ping takes to come back, and that's how it works out its distance to an object. A bit like a bat doing echolocation, or a porpoise, or a dolphin. You can learn a lot from nature. A lot of technology that we have today is basically stuff that's been inspired by nature. And here we have our sensor, and basically what we do with that is, it has 4 pins. We just plug it in so that, I would say, plug it in at the front of the board, and we just pop it in, and it should just, actually we'll go a couple of pins back. It doesn't really matter, as long as you've got each pin in an individual hole. I'll just show you how I've done this so that you can see it. So I'm the second row back from the front, and roughly in the center. And you can see here, as they said, if the robot looks like it's looking at you, you've got it right. It's in the correct position. So that's us to that point there. Now we have the part of the build where we need to wire up the sensor. And this is a little bit complex. On the robot page, where we have on the first page where we have the description of how this robot is built, in that video he has a really great diagram of how to wire this up. And I would suggest that you definitely watch that video carefully, but I am going to try and do that here as well, so that you've got enough information here to just go from this video. So that's what we will do next. Wire up our ping sensor and make sure that it's all correctly wired. Then we just need to get our motor shield on, and then the robot is assembled. Okay, so we want to use these wires that we have, which are male to male, which they're great. They've got a pin in them, which means you can just plug them into the Arduino and into the breadboard and everything else, which is fantastic. But because we want to actually take our motor shield and crush it down on top of the Arduino, while there's wires in there, that's a bit of a problem. So what we're going to do is we're going to just strip one end of these cables so that they're able to plug in, and then you can push a pin in beside them. So what I've done is I've just stripped the wire, just like we did when we were preparing our cables for the motors. So what I'm going to do is, I'm just going to quickly show you how to do that. I'm using the same coloured wires as in that diagram, just to keep things simple, so they make sense. So we just cut off the pin at one end. We only need to cut it off at one end because we're plugging the other end into the breadboard. And we're just going to strip off probably about 4 or 5 mil, and there it is there. And that is going to be pushed into the socket of the Arduino in the correct place, into that connector. Just show you the connectors are here, and we have to select the correct one and plug it in, and then the shield will go on top. So we're going to I'm going to prepare all those wires, and then I'm going to quickly show you how to wire it up as per that diagram we were just looking at, and then we'll install the motor shield. There are some issues with the power too. I know that in his final video he's got what looks like 2 9-volt batteries sitting on top of the robot, and I think that this is going to be woefully underpowered otherwise. So what I'm probably going to do is I'm going to build it as per the instructions, upload the software, and then see whether the robot is very, very slow. And I have a sneaking suspicion it will be, or it might not even work. So if that's the case, we'll do the modifications we need to do. But I'm going to follow the instructions as per the way they're presented, and then worry about modifying later on. I'm also not sure whether when you plug the power into the motor shield, whether it will actually supply power to the Arduino board as well once you take the USB out. Because your USB, when you're programming it, provides the power as well. Once you unplug it, the Arduino, you would normally plug a DC power source in here, And I'm not sure whether the actual motor shield power, which is where he connects his power, will provide power to the Arduino board as well. But that will all be revealed shortly. So I've showed you how to modify those wires. I'll now do a little bit of wiring, and we'll hopefully have this this unit complete and ready to do the programming of. Okay, folks, well, another strange anomaly has arisen. The sensor that I have, according to that diagram, the red wire would be going in the first pin here on the sensor, which is that one there. Sorry, that one there, the first, just trying to get this so you can actually see it, the first pin. The first pin is actually labelled ground, so that would actually be the black. So unfortunately, what we're going to have to do is we're going to have to look at what's actually on the labelling rather than what he's told us to do, because if you don't wire this correctly, it's not going to work. You'd actually have it wired backwards. So the VCC on here, on this breadboard, is actually the first, this pin here. So I'll show you on here. So what I'm going to do is just plug this in here and just show you where that is. So that's that first pin. So it's actually the opposite of what's on the diagram that he's showing us. So make sure that your first pin is that one there. So that's number one, and then we're going to grab our black pin, and that's going to go at the opposite end where it says ground. And as you can see there, you've got that in the ground pin. So far so good. Now the green is the one that starts with a T, and we'll just have a look here. Yep, and the green is the one next to the red on this, which is what it is in that diagram, but I don't know if it's in the same position. So at any rate, green goes in between next to the red. And finally the orange goes next to the black. And that's how you wire up your sensors. They're all in there nicely. So now we take our black wire back into the Arduino, and there's one on here that is marked ground. And it is the second pin along on this connector. And we're just going to slide that in now. At the moment, the wires are bunching up, and we want to make sure that when we scrunch them into the connector, that we don't scrunch them into the one next door as well, because that will cause a short circuit. So we want to make sure that when we push this down inside the connector, that we're pushing it all the way down to where the insulation is. That way it will make a good connection without shorting out the this is going to be difficult. So it needs to go in there without actually stopping the motor shield from coming in as well. So give them a good twist and pop them in. Now that's going to sit there until the motor shield holds it in position. So at the moment it wouldn't make a good connection, but when the motor shield is put in, it's going to hold it in position. Then we're going to grab our red, and I probably cut these a little bit too short. You probably want to have about 6 mil or so that goes right inside. So the red connector is, you leave a gap of 1, and you go 1 more further along, and it says 5 volts on the actual circuit board, which is the power that the Arduino uses, 5 volts. And you'll still be able to stick those pins in there. And then the green wire is going to the pin over this side, which is pin 12. And that's in there like that. And finally, our orange wire goes next door to it into pin 13. And we know about pin 13 because when we did our blink test, that's the one that's connected to the LED for blink test. So you're familiar with that output and what it does, what it can do. In this case, it's going to be probably, I'm assuming it's going to be receiving information from the sensor. I don't know whether it's an output or an input, but it's going to be getting information from the sensor. So we're going to pop that in there, pin 13. And now we need to get our motor shield and scrunch it down on top. Now this is quite a sensitive operation because we've got to make sure all the pins line up and that those wires stay where they are, because if they don't, the circuit is not going to work. So we get ourselves lined up and hopefully we scrunch those wires where they are and they stay where they are and everything works like it should. Wires are scrunched in on that side and on this side as well. And as you can see, they're all still there and hopefully they've made good contact and we haven't shorted anything out. And that's your motor shield on. And now, as per the instructions for the motor shield, that's your power in. Positive and ground is labelled, so the red wire from the battery will go to the positive and the black to the ground, and then we wire up our motors. Now, I have a sneaky suspicion, because this is a DC motor, that these are supposed to be wired up in a particular order as well. So once I fire up this robot, if it does actually work, if it's behaving strangely, it may be because I've got these wires around the wrong way, which I'm going to find out. So we just give them a bit of a, sorry, I'm off camera here. I'm just giving those wires a bit of a twist. And at the moment we're working with the two wires from this side of the robot, a brown wire and a red wire. Like I said, I made these different colours so I knew which wire, which motor they're coming off. And we're just going to loosen off this little terminal block. Now, as you undo the screw in this terminal block, what it does is it allows you to, as you loosen the screw off, it allows you to slide a wire in the front. So I've loosened that screw off, and I'm just going to slide that wire inside that terminal block and then tighten it down on it, and it should stay where it is. And that wire is then connected. So we slide it inside the terminal block and screw it down. And that's screwed down now and made a good connection. So now we get the other wire off that motor and we put it in to the connector next to it. So we loosen off the terminal block. Slide the wire in and clamp it down. Oop, it's come out. I'm going to get my jeweler's screwdrivers. They're a little bit finer. This lets me get in here a lot easier. that's that wire in there. Then we get the two from the other motor, which is the grey and the black wire. And we loosen off the terminal block. So the middle one is left empty, okay? And the motor goes either side when you wire it up. That's that one done. And finally, for the motors at least, we put our last wire in. And screw it down. That's that one done. So, as you can see here, you've got two happening in the top and two happening in the bottom. And then we've just got this connector here. One is marked ground, that'll be the black wire coming from the battery case, and the other one is M+, which is the positive. Now, like I was saying, I have a sneaking suspicion that this is going to be severely underpowered, and I'm not even sure whether this will actually power the Arduino board as such. The other thing I'm wondering about is whether the thing's going to start to drive away when you plug it in. So what I'm going to probably do is I'm going to try and create a switch by going via the breadboard. But for the moment, what I'll do is I will plug in the ground and leave the positive lead not connected. That way, when we put our program into our Arduino, the shield will not have any power to it, and hopefully the Arduino will only be powered up, and then we will plug in the positive lead and see whether the robot actually works. So it remains to be seen, like I said, whether that's going to be adequately powered or not. So that is the full construction of the robot. I'm hoping that that has made some sense, and I'm hoping that we'll get somewhere when we actually program it. So that's the end of this video. The next video will be all about how to download the library for the motors, because you need the library motor, the library for the motors in your Arduino IDE, and then we're going to download the sketch, because the sketch won't work without that library for motors. And once that is done, we will program our robot and see whether it's going to work or not. So fingers crossed we don't blow anything up, because if we do, yeah, it's a long wait for spare parts. But anyway, we shall see. I'll see you in the next video.